Thanks a lot, really, Mike. Thanks for thanks to the whole NSRR team for this big opportunity. Today we will share with you also with the sleep community and with you guys this tool this called SLEEPYLAND. SLEEPYLAND, it's actually a one-year project founded by Swiss universities. Mainly, it was the Swiss Open Research Data Grants Program. So you can imagine that the main goal of this project was to develop something to then release to the community as an open source tool. And the focus of this tool is to develop something to evaluate existing automatic sleep staging algorithms and evaluating all these algorithms fairly on this whole big database that we have from the NSRR. So the main session will be mainly divided in three parts. In the first part, I will just take these 10 minutes. That means it's really important that you all are actually that you have the SLEEPYLAND tool installed on your machine. So it's gonna be a sort of setup procedure. You're gonna go through the Mac OS and Windows. The second part, I'm just going to take up to 30 minutes to present the project, the tool itself. So the goal of the project, the data set that we use, all the models that we used, and so on. And finally, hands-on. So mainly we're going to navigate together into the user interface. So how to use the tool, the UI, and the notebook that we are exposing. Then, so we're gonna have the short break, and if you have time later on, we can discuss about the tool. And this is a big opportunity indeed because I can receive all the insights from you all. And please remember that we have these two people, so Alvise and Matteo, that are indeed part of the team, and you can always ask them if you are gonna have some problems regarding on the installation part. So the first thing I'm gonna do is to install the tool together with you. So we should just open if you don't have done. If you didn't done that before, please just follow these instructions. So go on the web browser, open your web browser, and type github.com/biomedical signal processing. So this is the place you will find the repo. The repo is called SLEEPYLAND. So you click on the project, and you just need two files. Whatever you're running it in Windows or Mac. In that case, I will install all in my Mac machine. So I'm gonna first download this .sh file, macOS setup. I'm gonna download it. Then the other file that I need is this other one, the Docker Compose YML. So please click on it and then download this file. After you download both the files, you should have these two files into the download folders. So what I'm doing, the first thing I'm going to do is to create a folder. I'm on my local machine, on my desktop, I'm creating a folder. I'm calling this folder, that is actually the project where I'm going to move everything, my SLEEPYLAND. Let's move these two files that I downloaded from here to the new folder, so the folder that I created. Then the next step is to let to execute these .sh executable. So the first thing I'm gonna do is to open my terminal. Just go there. Let me see. if you do here, I guess you see my terminal now. So let's move into the folder that I have created. You see, I copy paste the path. So I'm in the desktop, my SLEEPYLAND. You see, you now see here the two files. And the only thing that I have to do here basically is to run it into my local machine. Permission denied, yes. So we have to change the execution mode. So just type ch mode plus x dot slash mac, then type enter. So in that case, it is now a file that can be executed, and then press enter. So what I'm doing right now is just, if you're running it locally in your laptop, in that case, you are the first thing the tool is trying to do is to install Docker. So if you don't have Docker on your machine, this is the first thing that it's going to do. So installing Docker on your local machine. Once you have Docker, that is actually the instrument, the software that we are using, and on which the SLEEPYLAND tool has been based. Okay, you may be required. You see, he's asking me to insert the password. So I inserted my password and press enter because it's asking me in the permissions to then install Docker. You have few exceptions in Windows, so then I'm gonna maybe show you also one demo in Windows to let you install also on your local machine in Windows. So once you start it, you see it's verifying Docker, is starting the application. Docker is ready. I can show you that. I had on this other screen the Docker desktop popped up, and at that point we are downloading, in technical terms, pulling some let's say packages, technically some images that we need into our machine. So basically, if you are using, if you have also opened the Docker desktop at that point, you should see into these images. You see the list of images from SLEEPYLAND, from the Docker Hub, and then during my main session, the theoretical part, I'm gonna maybe tell you something more about Docker. And these two concepts of images and containers, what are these stuff? But overall, this is what we are doing, right? We are downloading what we need to run SLEEPYLAND. And more or less, you will need up to 5-6 minutes, I would say, depends also from your connection, to download to download the whole tool and all the stuff that you will need to run SLEEPYLAND. You see, we are downloading the GUI, the image for the GUI, another image. I'm going to explain you all later regarding all these images. Now, once we are downloading all the images that we need in my local machine, one thing that I want to show you is to actually how to do that in Windows. So what about Windows? In Windows, it may be that you may run into some problems, let's say, regarding the execution policies and the administration. You should run it as administrator. So in general, please, if you're gonna have some problems, experience of problems here on your local machine, just type in the Q&A, and Alvise and Matteo, they will help you. In general, the procedure is more or less the same. You have some compatible systems, Windows 10, 11, and actually, I'm just showing you the same stuff we did in the Mac, in my local Mac. Basically, you go on your GitHub, in the repository, SLEEPYLAND repository. In that case, what you need are other two files. So this Windows setup file, you need to download this Win setup and as before, also the Docker compose. You see that you are saving it in your download folder. I can skip a little bit here. See, I'm doing the same stuff, downloading it, putting in the download folder. Again, create your new folder, call it as you wish. In that case, it was SLEEPYLAND test. And then see here, we are just moving what we had in download folder to the new folder. And at that point, once you move it, you open your PowerShell into Windows. So type Windows PowerShell, run it as administrator. I'm sorry, it's just then I'm going to explain you why I had this window popped up. So run it as administrator. So you will see that you have to do the same stuff now, right? You have to copy paste the address where you have all the files that you downloaded. So into the new folder. So CD and path where all the files are placed. And then again, type /win setup to then start all. At that point, I can tell you that, okay, you need Docker, but in Windows, there is another stuff that you are downloading that is called WSL, Windows Subsystems for Linux. And sometimes it may be, so at the end of this whole procedure, it may be that whilst you are installing Docker, and so during this process, it may be, you see, in that case, in this video, we already had WSL. So it may be probable that you don't need to restart your laptop. So if you are going to experience this problem, and so you need to restart the laptop, I mean, it's up to you guys, but I mean, I don't know. It depends from one laptop to the other. It may take some time, but is the only way to then install Docker desktop and this additional WSL part. This is actually that we discovered yesterday because we had this exception on another machine, Windows machine. So once you finalized also here in Windows the installation, Docker desktop, you are installing all. Once you have Docker, you see you accept, you skip it here. So you're waiting to start. In my Mac, it was directly, it was starting directly the Docker engine without, it was not asking to me to accept, skip, etc. But in general, once you have Docker desktop, Docker engine running on your machine, at that point, SLEEPYLAND, so we're gonna pull and download all the images from the Docker Hub repository. And so that's what we are doing here. So I'm gonna stop this video. Just going back to at the end of all this procedure. So if I go back on so here, you see at the end of the whole procedure, I downloaded all. You see starting Docker containers. I'm starting, you should see all these containers started. You will see it here, green, or here is the same. Here you have the images with these dots, green dots, and on the other side, you may also have a look at the container itself. So at the whole SLEEPYLAND projects with all the containers that we are exposing. If you see that, and so you see it's running actually, so I'm not gonna stop it, but in that case, it's running on my machine. It is gonna directly open the web interface in your default browser. So for that reason, if I go back here, for that reason, whilst I was playing with you before, so showing you the video, we had this UI opened. And you should have, this UI open on your localhost columns and on this port. So 8887. This is the default port that we are using to expose the the container again. Then I'm going to explain what does it mean, what is a container. But in general, this is the main interface of the SLEEPYLAND AI. If you are here, it means that you know, everything's going. I mean, it was well installed, so we can proceed with a main session. But please, maybe what I can tell you, if you are still trying to install the whole software, whatever it is, on Mac and Windows, please write in the Q&A, because it's really important. It's really important for this third part. So I'll say, I mean, that's also, now that I have all installed on my Mac, what I want to do is to, yeah, these were actually the slides where I was supposed, I'm sorry, I forgot, I was supposed to tell you that there is also one other exception. So if you are operating on an institutional machine, whatever it is, it may be an hospital or sometimes also university systems, the process is likely to fail, but just because of permission restrictions. So it's all about that. So if we're going to experience these kind of problems, let's try to solve it in the chat again. And here I'm just reporting a list of incompatible software and hardware, whatever it is, in Windows in both cases and also in Mac. But what I can tell you, if you have something like recent version of Windows, recent version and hardware of, you know, Mac OS, you should not have any problem, because it's all about the installation of the Docker desktop. Right. So let's start with with this theoretical part, just to let you better understand what is SLEEPYLAND. We are talking about sleep staging. I guess you all are familiar with sleep staging. So what we are trying to do is to extract the sleep cycle information with SLEEPYLAND of the whole night. So as always, we start from our PSG, polysomnographic signals, meaning EEG signals, EOG, and EMG signals. We know that the doctors, they usually segment the whole night into windows of 30 seconds. These are what we call epochs. And then for each epoch at the end, we're gonna give, so the physician is gonna give the sleep stages. So in that case, it was N2, N2, and then 3. Now, what we are trying to do with SLEEPYLAND is to do it automatically, or at least exploiting algorithms that are solving the task, exploiting AI. We know that is a standard, it may be seen as a standard classification task, where we give an input to the algorithms, these epochs, or sequences of epochs, and at the end, the algorithms are supposed to give you an output, the sleep stages. Now, why we wanted to develop SLEEPYLAND? So which kind of goal we wanted to reach? The first one was indeed to be able to, given all the data, the recordings that we had on the NSRR report, was to be able to manage, process, and overall extract all the sleep parameters and pattern statistics from all these recordings. Now, this is something that I don't know if you are familiar with Luna. This is another software that has been exposed in the NSRR community. This is something that you can already do with Luna. So we are actually also exploiting Luna for that specific tasks. What I have to say that the main goal in SLEEPYLAND is that one. So the main goal is to provide for each sleep recording a sleep report, but as a report that has been generated by different sleep scoring system, what we call the automated ensemble of deep learning sleep scoring system. So what we are releasing with SLEEPYLAND is this repository to be able to benchmark all the high-performing deep learning-based scoring algorithms. But I have to say one big pro here is that we all these algorithms have been in SLEEPYLAND retrained fairly and evaluated, I would say fairly, because all of them have been indeed retrained and evaluated on the same data sets. So we're using the same set of data to retrain all these algorithms all together. And at the end, the system is going to output all the single prediction from the different models, but also the ensemble of these prediction. So this was the main, let's say, the main goal of this tool. Why we wanted to do that? Because, I mean, I'm sorry, this may be a little bit outdated, but the limitations with all these different sleep scoring algorithms that we had were that the majority of them were trained on low quality and poor data. So meaning maybe the data were not enough, were not heterogeneous. And another important thing is that only few of these algorithms have been evaluated on out-of-domain data, so resulting in poor generalizability on the different hardwares and different sleep labs. So I'm going to take another, all these algorithms were not, I would say, robust on data coming from distributions that the algorithms never seen. So here I'm just highlighting a few of these studies where actually some of these limitations were have been tackled, but overall have to say that to date we didn't have before SLEEPYLAND a tool to fairly compare all these algorithms. So to fairly train, validate, and test all these algorithms the same set of data. So this was our main aim. What we did was to exploit a lot of data. So all the data sets that we had, you see on the left, it's a list of data sets that we're exploring from the NSRR. And all these data sets here have been trained in SLEEPYLAND, have been used in SLEEPYLAND to train, validate, and test fairly all the algorithms that we included. On the right, you have what we call the out-of-domain test data. So all the data that we decided to keep out, so to not use during the training of all the algorithms, and we used all this data just as our test set. And what I want to highlight here is that you see that we have also these other two databases. Mainly, I have to say these one stages. That one BSWR stages is a database that actually you will find on the NSRR. That one is still not open, but these are quite rich data sets because here we also, I have to say mainly that one is from the University of Bern, and here we have actually a lot of subjects, a lot of polysomnographies, and a set of sleep disorders that are not only about OSA patients or sleep disordered breathing indeed patients, but in general we have a high heterogeneity in that database. So it's really good to have and to use to then test the algorithms. Here I'm just highlighting the data that we are currently using, or at least the data that have been used in the models that we are currently exposing. So in the next, I would say 2 weeks, we are planning to expose all the models, the pre-trained models, but pre-trained on all this list of data sets. And who knows, maybe in the future we're gonna add other data that are coming into the NSRR repository. So here, I just want to show you what is the workflow. So what we are doing in SLEEPYLAND. So starting from the NSRR data, this is this first step where we are gonna harmonize the data. With harmonization, we just mean resampling all the data, all the recordings coming from the different data sets, and select the set of channels that we want, or at least that we need to give an input to our algorithms. So mainly I have to say EEG channels, EMG channels, and EOG channels. So once we harmonize the data, this is the data that we call our input data. We split the data in training, validation, and test. And with this data, then with this split, we then at the same time train all, at least this is the plan, to train all these algorithms. I'm sorry, this is the plan because at the moment we are not exposing all these algorithms, just a subset. But in general, the plan indeed is to train the high performance algorithms in the same way. And this is what we are doing at the moment. And then you have the third step. In the third step, we want to evaluate the performance of all these algorithms. So meaning benchmark all these different algorithms in terms of accuracy, precision, recall. And the benchmarking, of course, will be done or has been done on the testing data. So on the data that we decided to leave out. And yeah, among the visualization evaluation tool, we are also exposing some plots like hypnogram, hypnodensity graph. I'm going to explain that in the UI once I'm going to show you the UI. And we are also computing all the sleep metrics, for example, total sleep time, sleep efficiency, and so on. Another additional features that at the moment we are exposing is to indeed expose also the ensemble of the prediction coming from the different models. At the moment, it's just a soft unweighted voting. I'm going to explain what I mean with soft unweighted voting, but it's not super smart. We are, of course, working on other techniques to ensemble the predictions from the different algorithms in a smarter way. Now, so yeah, in this slide, I'm just highlighting the models, the three deep learning models that at the moment we are exposing, where we're planning to insert also all the others. So as you see, we have different blocks. In the first part, the challenge was to, okay, let's have one block that is gonna be able to download all the data from the NSRR, harmonize all the data. In the other block, we need something that it's able to process all this data and run, the algorithms, the pre-trained algorithms, and let them run locally, mainly. And another part where the user should be able then to visualize and evaluate all the different algorithms on the NSRR data at the moment. But just a small spoiler, with SLEEPYLAND, you will be able, or at least we are trying to let you also be able to do and perform the predictions on your own data, so meaning your own EDF recordings, your own EDF files. Right. I just want to spend a couple of words on the kind of software technology that we are using in SLEEPYLAND. Is called Docker. Docker is a platform that allows applications, in our case, think at all the sleep scoring algorithms. So allows applications to run into independent containers. So in Docker, I can mention four different important parts. The first one is the Docker image. So Docker image is actually a static blueprint that contains the application or the algorithm in that case, and all the dependencies. So all you need is the script, a Docker file, and once you have the script, this Docker file, you are able to build your Docker image. So Docker image, actually, it's something that you can see as a static, indeed, the static blueprint that contains your application. Just to maybe show you what we have here. So going back here, you see we have different images. These are the images that we pulled from our repository. So in these images with different tags actually are the ones that I was mentioning before. So we built these images and we exposed these images in our hub. So this is the most important, let's say, part of the in Docker. What is a Docker container? This is actually what is running at the moment in my local machine. they're actually running instances of a Docker image. So you saw that I had different images, I have at the moment different containers running on my local machine. Then we have another concept that is important, that are the Docker volumes. The Docker volumes are file systems that are mounted into the containers. And these are really useful because in that way, with our volumes, we can preserve the data that we are generating via the container. So mainly it's a place where you can store your data. Just think at Sleepyland, you need something to store the data in input and also the predictions that you will have in output. One last thing, in Sleepyland, we are exploiting the Docker Compose. The Docker Compose is a tool and is used to define and managing different containers. So you're already imagining that we have different applications running in parallel, different containers doing different stuff running in parallel. With this technology, with Docker Compose, we are able to actually manage different containers, and all these containers are actually linked, and they can talk mainly with because we are exposing our input and output volumes. I'm going to show you what I mean with that. Yeah, and these are the images that we are, the images that we are exposing in our hub Docker are, the one that I showed you before. So Docker Compose. In Docker Compose, as I mentioned, is a tool to define the running multi-container application. So let's have a look at Sleepyland. Sleepyland has different images. The most important image is the manager. The manager, it's important because it's the one that is handling all the communication between all the other containers, also called services. So all the other containers that we have are the download container, something that we use to download locally the data. This other container is actually the harmonization container. The useLeapyland container is the container where we have all the algorithms. We are exposing the deep learning and machine learning algorithms, the pre-trained one. Then we have the container of the GUI and so on. So the manager is important because it's via the manager we are always talking with all the other container. And then we have the top level volumes, so input, output. These are really important. These are actually the manager and the top level volumes are the core of Sleepyland, because thanks to the input and output, in that case, we can share the data between all the containers. So these are the places where we are, exposing, for example, the prediction. I can go back again a little bit in my local machine, and I want to show you that. When we installed the Sleepyland tool, you see that we generated these volumes, these folders. Also that one, and then I'm going to also explain that one, this folder. But these folders are the one that we are going to exploit, and these are the one that I'm now mentioning here. So starting from these two images or two running containers, we decided to develop all the others one. So the one for the data downloading, the other one for the data harmonization, mainly indeed harmonizing the data. For us, it means resampling, extracting the channels that we need, and of course, have an harmonized format. You can imagine that we have different, for example, annotation format from different data sets. In that way, we are also harmonizing all the data. Then we have, the container with all the sleep staging models. So here we are exposing at the moment uSleep, DeepersNet, Sleep Transformer, and also YASA. YASA is the only exception. We decided to include YASA, that it's actually a feature-based algorithm. It's really popular, I have to say. And we are also planning to expose other feature-based algorithms, to mention one, POPs from Luna, for example. Then you have also these other container, that is the container that is dedicated only for the user interface. Just to mention, these are all independent containers, so they are running in parallel in our local machine, and they are able to speak one with the other via the manager. So with the UI we are exposing is just a Flux framework that has been designed to run on a local machine. So again, local machine. All the data that you are gonna upload, for example, or that you're gonna, also your own data, will never leave your laptop. So this is important because sometimes, you have problems. I mean, we all know the problems with the clinical data. And then we are also exposing this other important container. To me, it's really important because this is actually the way you can interact with all the other containers via the notebook, so via Jupyter Lab notebook, so coding in Python basically. And here we also decided to include all the stuff that Luna developed via the Luna API. That is something that has been exposed via maybe last year, more or less, from the NSRR. So of course, it is scalable because the advantage here is that you can imagine that once you have something, one additional, I don't know, algorithm that is not only about sleep staging, but maybe something else, you can add it on top of it and let him like dialogue with all the others. So, but in that, I mean, in this tool, let's focus on the sleep staging models. Before diving and going directly on the tool, so hands on the tool, I want to just show you something like some results that we have at the moment. So again, I'm just showing you what we achieved on the test set data of the NSRR. At the moment, we are just using this one in training, this list of data sets. And then I also report some metrics of for each model that we are exposing on the open access data sets, and this one, the BSWR, that is our heterogeneous at the moment private data set. Again, these are just preliminary results. You see, we are reporting for each model, uSleep, DeepResNet, Sleep Transformer, the metrics in terms of accuracy, macro F1 score, F1 score for each class. And in this first row, you see we are reporting numbers on the test set data, NSRR that we had in the test split. The one that we didn't use in training, the one that are open access data sets, and the other one that is actually the most heterogeneous one. Indeed, you may already notice the main are the numbers. If you see on the BSWR, we are actually achieving an MF1 score on all the models that is lower on average compared to all the others. So it's just again, I'm showing the results for each model. So uSleep, DeepResNet, Sleep Transformer. You may in general you may already see that we cannot came up with conclusions because we have to analyze all the results, all these results that we have. But in general, at the moment, what we are noticing is that on average, there is not a big difference in terms of performance between these models. But what we are noticing is that there are some models that are I don't know, achieving an F1 score in N1 higher compared to the N3 with another model on a specific set of subjects. So we are just now we are trying to understand if one model or the other model is specializing on a set of a subset of subjects in doing a good job on on the N1 class, for example. So again, here I'm showing instead the results that we achieved on these models pre-trained on single channel EEG. When I say single channel EEG, it doesn't mean that we choose just one derivation. We are using all the possible derivation that we have from the NSRR training data with EEG channels. In that case, before it was just all the possible combination of EEG plus EOG channels. Then maybe I'm going to show you the output results from the UI, and you will also understand what I mean with this combination of EEG and EOG. And here we have the results from the single channel EOG, and actually these were the results with the lowest performance overall. Last slide. Ensemble. We are just here reporting the performance on the EEG plus EOG pre-trained models, Sleep, DeepResNet, and Sleep Transformer ensembled. Overall, of course, we are just noticing that we are reaching a plus 1%, plus 0.01% in terms of macro F1 score. But I mean, to be honest, I have to say these are preliminary results. So we have to do some statistics. We have to, divide also the data into different disorders to better, understand all these models, what are they doing. But in general, I mean, we are happy because at the moment we have all these predictions from all these different models where one important thing to notice that, I mean, I didn't mention, these are all models that we chose at the beginning because they've been already trained on a lot of data in their original study. And for example, that one is convolutional neural network based. This other one is using recurrent neural networks. This other one is using transformers. So these are also different technologies, and also we were curious to understand, if the kind of performance that we can reach. It's mainly about the architecture itself, or it's about the data that we are giving in input to these algorithms. Right. So that's the last slide. What I want to do with you now is to indeed dive into the tool. So this is the main page. I hope that you are all here. What you have are different tabs. The main tab is that one, the home, of course. All these other are tabs that we're going to use to visualize the results. So in the home, if you dive in the home and you click on tutorial, you will have you open this list of notebooks that we are exposing. I mean, SLEEPYLAND notebooks. These are, we are exposing these notebooks to let you better understand the tool, also to let you understand how to use the UI. So in general, here is really a fast, a really quick guide on how to easily use the main function of the UI. I'm going to show you how. What we are planning, this is worth mentioning. You here have the link on, this link to our playlist. At the moment, you just have 2 videos on how to install SLEEPYLAND on Mac and Windows, but we are planning to expose also other video guiding you on how to use the user interface. So this is the notebook. I would say, let's first show you how you can use the UI. The second button, you see you have NSRR data. This is the button that lets you do your analysis on data from the NSRR. So if you click on it, you have 2 options. You may upload the data. So let's say that you already have one data set or some recording from the NSRR. At that point, you can click here. The other option is to first download the data if you need it. So if you click here, download the data, you notice that you can select among the NSR data that at the moment is supported in SLEEPYLAND, once you select one data set, you can select the recordings that you want to download. Let's say these 2 recordings. And you need the token. So you need a token. This is something that you will have once you do a request. So let's say that you want to use a data set. Maybe I should have something here opened. Yes. In general, this is the way you're gonna you're gonna achieve the token. So you request data access to one of these datasets, for example. When you go to the whole procedure, you receive the token, and this is the token that you should insert here to then download these two files, for example. One other important information, you see here you have some marks. So in this way, we are just telling you, at least specifying which recordings we use to train the models. So we know that, for example, this recording, this is just a big difference between the deep learning and the YASA. So all the deep learning models have been trained in the same way. So in general, if you find this symbol, it means that this recording has been used to train all the deep learning models. So of course, if you use it to run some evaluation and perform and compute some metrics, there is a bias because it was in the training set. So make sure to select if you wanna evaluate on data on models. For example, use Leap to select data that have not been used in the training. So let's go back. So let's go back to the upload data. So I'm not going to download any data here. If you click on upload data, you have different options. Let's have a look. For example, I already have some data from this dataset ABC. So in this first section, what I have to do is to select a folder. So choose some files from this database. So if I choose the files, you see I have, let's say that I downloaded the files from the ABC, these 3 files from the ABC dataset. Usually what you do when you download the files is to download the EDF and also the annotation. So this is the kind of formats that you need. All the stuff are also well described in the quick start tutorial, but this is the kind of format that you need to have to be successful in uploading, or at least in mapping these files on which you want to run the evaluation and all the models. I'm not gonna use these data sets. I'm gonna use some toy recordings, learn. So you don't need to upload anything. So in that case, if you click learn, automatically we're gonna move the data in your input volume, input folder, and then you will find in output everything. So just click on learn, then insert the output folder name. So meaning insert the name of the folder on which you want to find your results. In that case, I'm going to type learn NSRR tutorial. Then you're supposed to select the channels on which you want to run the analysis, the evaluation, so the models. You see, you have different options here. So if you want to run it just on EG channels, select one or all the EG channels. In that case, you see you have just 2 channels. I want to show you something else. If I go, for example, here, other database, you will have a list of different channels. These are the possible channels that you will find in this kind of recordings coming from these datasets. In that case, the recordings that we included in Learn, they had all these 2 channels, the central C4, C3, and the EOG, these 2, left and right, as always. So if you want to run just on the EG channels, so exploiting the models pre-trained in a single EG with just single channel EG, you do that. Otherwise, you select none and you do the opposite. So you select all the channels, EOG channels, and the evaluation will be done on the models pre-trained on the EOG channels. With you, I'm gonna use both because I want to show you how the models are gonna give you prediction if I select both. So all the EG channels and all the EOG channels. And among the sleep staging models, I can select these 3, for example, the deep learning based. You see here, you also have some, if you click here, you're directly, you're redirected You know that. Anyway, you are directed to the publication, so to the main so information about the models that we are exposing. This ensemble, as I mentioned, is just a soft unweighted voting of the probabilities that we are computing via these models. Next step, press evaluate. You see you have two different buttons, evaluate and predict. Why the predict is not enabled? It's just the evaluate. I click on evaluate and then it's processing. Why just evaluate? Because actually I'm in that way we have not only EDF, we are not running predictions, let's say, but we want to evaluate all these models in the set of recordings on the set of recordings, and we want to evaluate their performance on this set of recordings. So we have the EDF and we also have the annotations. This is just a way to compare these models. So I want to show you something. Once I click on evaluate, remember this is all running on the CPU. It's not GPU optimized. So it may be a little bit slow. When I say slow, it means I selected 3 models. So it's going to be more or less 1.5 minutes, 1.5 minutes for each recording. We are in Learn, we had 3 recordings, so it's going to be 4 minutes more or less. In the meanwhile, I want to show you something. So if we go back in the Finder, you see in the output, we already have something. So in input, before we didn't have anything. So we moved the data on which we are running the evaluation. In the output folder, so that one that we created via the UI, you have the Learn NSRR tutorial, you have DeepResNet. This is the first model on which we have the prediction available. And as you can see here, what we have are some predictions from all the possible different combination of channels, in that case, EG plus EOG, so C3, A2, EOG left, C3, A2, EOG right, and so on. So you have the prediction in different formats, NumPy file and .anot. This is really important, this format, because this is actually the same format that, so we are exposing a format that has been suggested by the NSRR community in terms of, Luna has been exposed with annotations that are coming with this format. I don't know if I'm able to open the format just to show you what I mean. Yes, I have it here. I'm sorry, maybe here I'm going to show you the format. You see, you have the kind of plus distance channel, start, stop, and some metadata. Basically, we are saying we are inserting in this annotation file something that it's about the staging. This was a prediction in awake from 0 to 30, see, 30, 60, 60, 90, and then we have the probabilities for in each class given by the models. So let's go back here just because I want to show you something else. Of course, you have the same structure for all the models, so DeepResNet, USleep, and Transformer. And for all these models, so at the end, what I will look at is that the majority is actually the majority voting of all the different predictions that are coming from all the possible combination that you have. And the ensemble is actually, so ensemble under ensemble majority, at the end, you have the prediction for each recording that you selected, uploaded, whatever, that are coming from, is the soft and weighted voting from all the different models that we selected. And that's ensemble. And you also see that we also have the true files that, of course, are useful to have in output because it's something that you want to use to compute some other metrics, for example, in the notebook. So let's go back here. So for sure now we should have all the results in the hypnograms, hypnodensity, and performances. So what we are showing here, you see, are in that case the hypnograms for each model. For example, let's open one hypnogram from the deep-rest model. Here you see you can click on top of it and plot, for example, just the predictions, diving into the hypnogram, or just the ground truth, or both. I agree is not the best way to visualize both, but if you click on compare data on hover, basically, you see you have the sleep epoch here and the sleep stage. You see I can compare them and see when, for example, here the ground truth was awake and the prediction was not REM1, so they were not agreeing. So the automatic scoring failed, let's say, in the comparing the prediction with the ground truth. So you have this kind of, you can download this plot, for example, you can do different stuff. You can, of course, zoom on top of it. And then you also have the results for all the other models and the hypnogram coming from the ensembling of all the models. Right. One interesting part, so at least you have the hypnograms, but what you can have are also what we call the hypnodensity graph for all the models. I'm going to explain you what we are plotting here for all the models. So let's have a look again to the deep-rest net. I'm sorry, something before getting here, something that I didn't tell you. You have also other two buttons, previous and next. It means that you can, visualize the recording number 1, recording number 3, recording number 2 in that way for all the models. So of course, if I open here, you have the S2, 1, 3, etc. So let's go back to the hypnodensity. Again, in the hypnodensity, you always have in the x-axis the sleep epoch, but what we are plotting here are what we call the cumulative probability. So a way to let you better understand what we are plotting is that one. So let's remove all the information that we have on all the different classes. What you see here, for example, in awake, are the probabilities of the model, in that case, deep-rest net, that you have in over all the epochs. So in that case, I can tell you that the major probability at the beginning here was of about 0.9, 0.9, 0.8. So here I'm plotting the probabilities that the model deep-rest net is given to that epoch at that time. So at that time, I have this probability. And what we are plotting with all the others sleep stages are the, you see the areas here are the cumulative probability, meaning that in that case, for example, if I show you all the results, for example, in this part here, the highest probability, the highest area is associated to the REM sleep stage. So we are talking about 0.8 probability to be in REM. So it's really much more powerful, this kind of representation, because you may actually notice and you see that it's not actually only about REM and 2 awake, is not 0, 1, but it's it's a continuous process. So from not REM, I'm moving to N2 and so on. So awake and so on. So if you at the end of time, if you compare it, for example, on the I don't know, we are looking here at the learn NSRR2, and let's have a look here also at the learn NSRR2. If we plot, for example, from 800 to 1000, the hypnogram, and again from 800 to 1000, the hypnodensity graph, you see here more or less we have an N2 prediction because the probability is higher for the N2. And this is what you have, right? So this is the final answer from the model, N2, N2, N2. I want to just plot the predictions. N2, 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 and then you have two RAM predictions, because if you notice here, from N2 you go to N2, and then from N2 you go to awake. So that's the reason why we are plotting the hypnodensity. So N2, RAM, awake. So that's the kind of information that we're plotting here, and it will be really useful because at the end of the time you may use for each epoch the probabilities coming from all these sleep stages to do something else, for example. It has been shown that these probabilities are really useful if you want to predict some disease, for example. And here again, we are plotting the performances on all these three different models, meaning we are reporting some metrics. This is just the average respective to all the subjects that we included. So you have different options here. You can even plot or report the performances just for one single file, but also for the overall average. So you have metrics on the left in terms of macro F1 score, F1, awake, N1, N2, N3, and REM, accuracy, metrics, recall, and precision. Of course, you have the confusion metrics here on the right. But what we think it's really useful, and this is something that we are going to update in the next releases, are the references. Meaning these are the kind of numbers that we computed on average. So these are the kind of numbers that I showed you before in my presentation. So meaning on average, DPRESSNet on all the data, on all the NSRR data that we had in test set, we had this performance. So you may compare on average, if, for example, not on the average of all the subjects, but for example, on the Learn NSRR2, if it's on average inside what you would expect in terms of performance of that model on the NSRR data that we took in tests. So this is the case when you are using the NSRR data. What I did here, it's actually something that you can obviously also do here in the notebook. So if I go back here in the notebook, you see that actually, of course, we are always in the localhost. So this address is always the same to say localhost, right? This is the port that we are exposing for the notebook. This is the port that we are exposing for the UI service. These are all running in the Docker. Just to show you something else, if you go back always in the Docker desktop, we know that the containers are running. So the Docker Compose SLEEPYLAND is running all these different services. And all these different services have been exposed in different ports. So this is the notebook container. So basically, if you want to open the notebook and you don't want to open via the UI, for example, you just type localhost columns and then type the port. So if I click also here, basically I'm opening another notebook. Right. So, and again, so as we are running all locally, you can see everything we had in input, in output. So all the stuff that we generated via the UI. And another important thing before diving into the one example of SLEEPYLAND notebooks that is indeed linked to the sleep staging, we are also exposing here something that may be useful for you. In general, we are exposing the files, the naming of the files that we used during training. So we are exposing, of course, some models that have been pre-trained. But if you want to know which kind of data we use to pre-train these models, for example, in this first training that we did, NSRR 2022, you can see, double click here and you see the subjects that we get in training and the one that we get in testing. Where we training, just keep in mind, is training at Val. training and validation set. Here is just testing set. So 2024 is indeed the whole NSRR datasets, list of datasets that we had. This is something that we're going to expose, and the same on YASA. This is actually the list that YASA, the author for YASA, Rafael Vallat, gave to us. Recognize indeed also here the subjects that he kept in training and the ones that he kept in testing. Why you see different data splits, for example, for YASA and that one, because in SLEEPYLAND we just pre-trained deep learning based models in the same way. So the FAIR training was just about the deep learning. That's also why YASA, is not super fair. For example, here, if you are doing some stuff, you want to evaluate on some data from the NSRR, and you also click YASA, and then you click ensemble, it's not super fair because YASA has been trained in another way. So I would run the ensembling just on the deep learning based model, at least at the moment. And then you also have the references metrics that are actually the metrics, all the metrics, global accuracy, macro F1 score, all these different metrics that we are reporting from each data sets, means, percentiles, medians, standard deviation, and so on. So all these metrics are something that we're gonna update in the next releases. Now, maybe the last thing another thing I want to show you is to maybe before diving into the notebook, something that I want to show you so the notebook here is something that I want to use with you because I want to show you also how to use SLEEPYLAND directly from the notebook. And mainly, running predictions, so doing sleep staging on the NSRR. In that case, we're going to use again learn dataset, but you can also do that, so sleep staging on your own EDF. So you have your own EDF. I want to do that. Before doing that in the notebook, what I want to show you is that, of course, you can do that also at the moment, also via the UI. I want to be honest, the tool has been optimized at the moment to run on all the NSRR data in the evaluation mode. So to benchmark all these models and the other models that will come. In my EDF option, at the moment, there are some limitations, I have to say. For example, let's say that I'm going to click on my EDF data. And I choose a file. I want to choose a file, for example, and I choose one data from the, this database. Okay, this is my own data set, and I have my EDF data, my EDF file. Output folder name. Let's call it PSWR. I don't know, test. You see here, you have something different. At the moment, the only option that you have is to select EG type or EOG type or both. But what we mean with EG and EOG type, we are with these two options, we are inferring the channels that you are reading from the EDF. So if you have standard channels, for example, 1020 channel names, standard F3 with mastoids, C3, etc. with mastoids, at that point is not gonna fail because these are kind of strings that we are expecting from the EDF. But if you have something that is weird and we didn't know that, for example, this EG channel has been named in another way, it might not recognize it, so it's not gonna work, or it's not gonna give you some prediction on these channels that you're expecting. And again here, so if you select EG and DOG and you select, for example, one or two models or more models, see here you don't have evaluate, you just have predict, meaning you will have some outputs. Let's run it in the hypnogram and the hypnodensity graph. No data, of course, on performances because you don't have annotations. But what you would have indeed in the UI, you can see your hypnograms, generated hypnograms and hypnodensity. And on your local machine, see you have the BSWR test folder. We selected the DPRESnet, YASA, and so on. So these are all the combination of channels that he's using because we decided to do that on the EEG and the OG. Right. So basically, you can use it also, running your own EDF. Of course, you have to wait, as always, a little bit. In that case, you see, the processing may be heavier because you are actually predicting on different combinations. And as I shown you here, in that case, for example, you have really a lot of combinations to then expose the majority voting on the prediction. Okay, now let's talk about, let's see if in this last maybe 15 minutes I can show you that. So how to use the notebooks. So here you have these two sections. In the sleep staging models, you have these two sections. So basically you can do the same stuff you did on the UI. But what I want to do with you is not just running what I already prepared, so what you already will find on in the notebook list here, but maybe it would be nice to go back here and see, go on my notebook. This is a space where you can actually create your own notebook to interact with the services, with the containers, and so on. So what I'm gonna do is to create a notebook under my notebook and name it my sleep staging. So let's have it here, just to let you notice something. Of course, here I can start to type, but in general, what I want to show you is that what I created here again is something that you will have here. So basically, once you stop, for example, SLEEPYLAND, what you had mainly in my notebook and also in output will be there. So you will always have something in my notebook and output. Why I'm not mentioning input? Because okay, at the moment, these are the EDF that I had because I uploaded it via the UI. But if I go back here, and in the home specifically, you have a button here that is reset. By reset, I'm resetting all. I'm not deleting anything from the folder my notebook, neither from the output folder. But what you will not find is what you uploaded or whatever you had in the input. I'm not going to explain the reason why, but in general, it was easier to then manage the data that all the models were reading from the input file. So let's go back to the notebook. So how to interact from the notebook with all the services? What we are exposing in the notebooks in general is this helper function that lets you interact with all the SLEEPYLAND services, where the services are the containers, remember. So the NSRR download container, the use SLEEPYLAND containers where you had models. And of course, this has been, it's something that has been done, has been implemented, and we thought to implement it in a way that you will always pass from the manager. So if you want to ask something to a service, basically you should, via indeed the library fast API, you should indeed request via a post logic. You should request, let's say, via a post request. You're gonna call something from another services, specifying the endpoint, and this is something that we actually detailed into the, if you go back here in the SLEEPYLAND notebooks, you see you also have this notebook that is called services. And here you will find all the different ways you can interact, let the services interact with each other, making post requests via the manager. So I'm not going to go into detail of this part, but in general, this is something that it's needed, that we always need in the notebooks to interact with the services. So let's start with, for example, what we did on the UI. So running sleep staging on NSRR learn datasets. The first thing that we need to do is to load data. So in this first bunch of codes, scripts here, we are just grabbing some data that you will find in the Luna API notebook. I don't have time to talk also about Luna in that session, but in general, you also have some data tutorial. The same tutorial EDFs learn that we're using in SLEEPYLAND are the same that Luna API is using on the other side. So we are just from the source tier, we are just copying, pasting, and moving the data into our shared volume, let's call it volume folder input. So if I copy paste here in my sleep staging notebook and I run it, to run it, remember, it's just Shift Enter. You see, I copied my EDF files into the input folder. These are the files that I have now. Now, let's run some predictions. So what we are going to do here is all the stuff that you see on the UI. So the first thing that we need to do is to get channels from a specified datasets. So the first function that we need, I want to grab, you see, you just have one cell here. So all the coding has been put in one cell, exposed in the notebook in one cell. So with you, what I'm going to do is to just, for example, copy paste the function that let you grab information about the channels. So getting information, retrieve the available EG, EOG, and EMG channels from the data sets we're going to specify. You see that in this function, we're going to make a post request. And the endpoint, that is actually the button that we were pushing in the UI, is called get channels. Of course, we need to pass some parameters. And the parameters in that case is just the dataset, the name of the dataset. So here, basically, I just scroll, I'm sorry for that, at the end of the cell here. Here, if I copy paste, so I just gonna specify the name of the dataset, in that case, learn, and I'm gonna calling the get channel function, plotting the response. You see, I mean, these are the channels that we are retrieving. So EG, EOG channels. So the one that you were seeing in the UI. So if I change here, for example, MROS, it's another dataset from the NSRR or the chat dataset. So with this function, I'm able to know from that dataset which kind of EG channels I had available. So at that point, let's say that we know which kind of channels we have. From the response, for example, I want to extract the EEG and DOG. The EMG is not supported at the moment because the models have been pre-trained just on the EEG and DOG channels. We need to define, so as you were, defining the models in the UI, you need to define also here the models that you want to use. So giving me a list, for example, I want to use the uSleep model and the YASA model. You do that, you define the models. And another stuff that you need to define is, this is actually something that it's coming from the uSleep implementation. So the one from Matthias Perslev, so the uSleep algorithm. By the way, I have to tell you something. I didn't mention that it's really important. SLEEPYLAND, mainly SLEEPYLAND, and also the harmonization part, it's mainly completely inspired by the codes that Matthias Perslev exposed. what we are doing, because the way he was managing all the data, the way he was feeding the algorithms in this repo was actually amazing. I mean, it was a nice way to retrieve data from different data sets. So the logic is there, and is the one that we use from uSleep. What we are doing with SLEEPYLAND is to add on top of it, so to re-implement, this is one challenge for us, all the other models that have been exposed, deep learning based models for sleep staging. And of course, this is a big effort from our side because you have to re-implement stuff that have been written, for example, in PyTorch or, with other logics and were not, not being implemented to to take in input some data, for example, that we are now using in this project. So as I was saying, define the epoch length. Of course, it's always 30 seconds. So this is always the kind of resolution that we want to have in terms of prediction for seconds for Windows. But if you're just using uSleep, what you can do, if you know someone who new may know the the model, you can also have prediction each 5 seconds, each 1 second, each 15 seconds, 10 seconds, and so on. So this is something that you can do, but be aware that it's something that you can do just with uSleep. So the result is that you have a much more finer hypnogram and hypnodensity graph, of course, with with some sort of a higher continuity from one sleep stage to the other. So what we need now is to call a function. This function, it's actually running what we did in the UI again. Auto evaluate is what we call auto evaluate. I'm sorry, I'm going here, up here. So this is the function that we need. This auto evaluate function, as you notice, needs an input. First of all, is performing two steps: harmonization step and evaluation step. So with this function, when we make the post request, so exploiting the function that I gave you above, so calling the manager. When I'm calling the manager and I'm exposing this endpoint that is called auto evaluate, at that point, I'm asking not only to evaluate the recordings, performing metrics and so on, but I'm also asking to harmonize it. So mainly the manager is first calling the container, so the block related to the harmonization part. And then once you have the data harmonized, you call the block for to perform the evaluation. So calling the models that you need. Indeed, here, what you need here is the folder containing the input data, that folder, the output folder name where you want to save the results that you will find in output, the list of EEG and EOG channels only in that case, the name of the dataset, again, learn, the models, and the time resolution. So I'm gonna run this shell. Now that we also have this function, we can for sure exploit it. So copying it and pasting it in our cell, in our personal notebook. We are just giving the information needed. So what you will see here, if I run it, the first thing is the harmonization part. So here, you are supposed to see something like, wait, something is not fine. Nice. Maybe we found a bug. I don't know what is going on. Let's remove this more. Okay, here you were supposed to I'm sorry, maybe I don't know what's going on, but in general, let's do something. Let's reset all, so removing everything from the input. Okay, and let's try again. I don't know, sometimes you may have some errors, but it is the first time actually. Okay, I will do it again with you. I'm sorry if I'm moving really fast from one side to the other. Let's go back and let's see here if I'm gonna rerun all. Okay, right. I didn't define the dataset, so it was not actually. It's something that I didn't run before. Actually, what I missed is that as we are doing all in the learn, you see, I had chat here. I left chat, but here I was defining to do that. I mean, I was asking to do that on the chat dataset where I didn't have the right formats. So let's rerun it. I'm sorry for that. And let's see now what's going on. Okay, right. You see, you had this list, and now that I called it, is just reharmonizing all, meaning, from EDF to H5 and the annotations XML to ADS. Sorry, my fault, actually. I didn't change the name of the dataset. We were running all on the learn, on the learn files. So once you have it, is still running, but in general, you did the harmonization, you go back and you check the output file. At that point, you see output learn is the folder that I decided to, where I decided to put the predictions on USleep and YASA, and you see these are the predictions that I have here at the end. Are the same. I mean, you will find the same format, so the same stuff that we did on the UI is something that you will find here. So, and again, also here in the notebook, you may exploit some other functions that we exposed. You see we run the predictions. Now there are some function, for example, hypnogram and hypnodensity graph generation. I cannot go into detail on the whole, function. Is that these are just two functions that are, I'm not making any, post request, or I'm not asking anything to the manager API, because in this case I'm just extracting information from the output learn. So I have information on the output learn. I give the folder and the models on which I wanna. This is the response, and the models for which I wanna have, the hypnograms and the hypnodensity. These are the hypnograms. And again, you also here you have, hypnograms for the USleep is the same one. So the same format that we are exposing in the UI for each subject and for each model. So USleep and YASA, and the same for the hypnodensity. So if you copy paste that part and we finished, we can of course also generate all the hypnodensity graph on all the different recordings. Right. Last part. We in the notebook actually we are in a place where you can use also other libraries. This is also an important part. You can import, for example, YASA and exploit YASA to do something. You can, for example, import a Luna API as LP and use Luna API to do something else. When I say something else, so interacting directly with the output, for example. And here is what we are doing if you want to compute some parameters, some metrics, sleep statistics, for example, time in bed, sleep period time, etc. We are exposing in this notebook, for example, some functions. Again, I'm not going to go into detail of the function itself and the metrics, etc. But in general, what we are doing, just to let you to show you, see, at a certain point we are using sleep YASA.sleep statistics, giving an input, what we call here sleep stages majority, that are actually the stuff that we are loading from the folder that is called majority, where we had the file for the specific model and the specific subject. So what I'm telling you is that now I'm just gonna copy paste everything here. If I run it, what you will have are some statistics, some information. So I wanna see overlay. Yeah, some statistics for each. I'm sorry, I'm gonna start from the top. For example, sleep, learn NSRR 01. You have statistics for time metrics in minutes and percentage metrics on the predictions and the ground truths. Maybe these two, yeah, but anyway, for example, these two are related to the first graph. So you can plot some statistics information from the predictions, so from the predicted hypnograms, and compare it with the ground truth. And you can do the same on the percentage metrics. Is something that it's really useful if you wanna, also not only plot this information, but just grab this information for each subject and then do something else or exploring it for your analysis a posteriori. And this is the same, this is just something that we are exposing from your sleep, and the same from YASA, just because we decided to do that on these two. But of course, you can do that also on the other models that have been supported in SLEEPYLAND. Okay, I will stop here. Maybe, that's all. I will maybe prefer to have a discussion, interaction with you all. Last thing, of course, you can do that via the notebook also on your own EDF. The only thing is that you have to, again, we do the same stuff. So data loading, sleep staging run, sleep staging prediction. When you run on your own EDF, the only difference is that, remember, you don't have the ground truth. You just want some outputs and evaluate these output. And you see is a different function that I'm exploring here. I'm sending a request to perform the prediction just on the EDF file. So the endpoint is the way we define it, and the way the manager recognize the command predict one. So predict on one EDF. Actually, this was the first name. It's coming actually from the first repo from Matthias Perslev. But at the moment, with this function, you can also call not only one EDF. You can give me a list of EDF, and you will then return in output. I can run it really quick. It's not defined. Import OS. I don't know why the OS is not defined. Huh. Okay. This was the first stuff that we ran, so the libraries were missing clearly. So let's go back here and let's see if we are able to do that. So running no, I'm sorry. That's because I moved from one notebook to the other. That's the only reason.
I think maybe should we pick this up in the breakout session afterwards?
Yep. That's all, more or less. That was the last part.